Hello again, this is Tony Verbsky. I'm going to be doing more trig equations. Section 10.6. It's kind of like this. The more I do, the easier it is for you. Um, some of these are really traditional, and then this book occasionally just pulls one out of the hat, and it's quite challenging. Just know in calculus, most of them are pretty cookie cutter, what you need to know. So um, just keep that in mind. This is a very important skill. The reason you study identities is so you can actually do this. So once again, we're on section 10.6. Solving equations again. Okay, well, here's traditional. Cosine 2x equals cosine x. There's identities, three of them for this. As you saw last section, we like quadratic equations. So I'm going to use, well, there's three of them. There's cosine squared minus sine squared. There's 2 cosine squared minus 1, and there's 1 minus 2 sine squared. I'm going to use version 2. So this problem is technically pretty easy if you memorized your identities, because now we have a quadratic. Oops. Started thinking about my next move there. And then you factor. Now, if it doesn't factor, you're going to be using a quadratic formula. You might as well just add 5-10 minutes to the problem. 1, 1, outer, inner, 2 on the out, 1 on the in. We want to go -1, so -2 plus 1. Feel like I'm teaching factoring again. That's a FOIL backwards or FLOY, do FLOA. There's only so many ways to factor. I was using a trial and error approach there, but because of the prime number here and the prime number here, it was actually doable. Cosine theta, -1/2, set that equal 0, subtract 1, divide by 2. Cosine theta equal 1. And those are both unit circle numbers, so cosine negative here and here. I know the magic angle is 60 degrees. Therefore, 120, 240, and cosine 1, that's just loads of fun at 0. And the book doesn't allow you to call it 360. But wait, they say use radian, so theta is 2 pi over 3, 4 pi over 3. And don't forget 0. 360 is actually, oops, 2 pi. The book doesn't allow you to use 2 pi. I always do in practice. Anyway, I usually just do the whole interval, 0 to 2 pi, bracket, bracket. It doesn't seem like in calculus that there's ever situations where they're, say, on this interval here. It's always on a closed interval or on an open interval. So find it a little different. Okay, where are we going next? Okay, so they go after the inequality thing again. So like cosine 2x less than cosine x. First, you got to know where cosine 2x equals cosine x. And we know this happens at 0, at 120, at 240, and technically at 360. I could use radians. Now you pick your favorite angle. I'm going to pick 90. And you're going for true or false. So cosine 180 less than cosine 90. Actually, let's go this way. This is easier to understand. So I'm going to get my eraser out. Easier to explain, not easier to understand. Same question, really. Cosine 2x minus cosine x. When is it negative? There we go. Now, so that's 180. So I got to do this math. Minus cosine 90. And cosine 180 is negative 1 minus 0. It's negative. So it's all negative in here. Now you choose 180. So you got to work cosine 360, which is like cosine 0, 1, minus cosine 180. I just did it. Negative 1, therefore 2. Therefore, since 2 is positive, and 270. I don't know if I know cosine 270. Yes, I do. 0. So it's cosine 540 minus cosine 270. And that's 0. 540 is hurting my brain. So 360 off from it. And 180. But that's negative 1. And it's negative. Therefore, this expression is negative on 0 to 120, 2 pi over 3. But it's 0 here and 0 here, and I want less than 0. So I must put a round bracket, union, 4 pi over 3, 2 pi, and I know it actually equals 0 at 2 pi, so you can't include it. And that's where it's negative. Do I like doing it like that? No, not really. I prefer to just do a visual. Oops, sorry, forever and a day. Y equals, clear, cosine 2x, cosine x. Let's check my mode. Let's work in radians this time. Window goes 0 to 2 pi. I like going every 15 degrees, and 30 degrees is pi over 6. So I like going pi over 12 ticks. Oops, helped if you go divided by 12. I never really, oh, actually both of these are between negative 1 and 1. So when you subtract them, the 3's will work. Graph. So there's your graphs. And you can see they intersect here, 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 and here. I said I was going to get I was going to upgrade my calculator. I grabbed the wrong emulator when I built this. Let's make the first top one bold graph. So this goes, when is the bold graph, right here, the bold graph, smaller than the not bold? Well, it's in this region here, and the bold graph is below the other graph here. And we know the two functions are equal at 0, 120, 240, 360. So it's below it from 0 to 120, union 240 to 360. I love that. Visual is way better than this inequality number line game. But then again, you play the inequality number line game your entire calculus career. So it would be best that you understand both, even though this is childish, literally freshman level, and in this, oh, who knows? I mean, it's kind of old school now. I teach high school, so math has changed a lot, but It's the way it used to be. Anyway, let's move on. No more venting. Okay. Oh, I see this coming from a mile away. 4 sine x, cosine x. Oh, here it is. I just know sine 2 theta personally equals 2 sine theta cosine theta. It's one of my favorite identities. And I see that I'm going to break the 4 up into 2 times 2. I'm going to circle this and replace it with sine 2x. Negative the square root of 3. Now we need to divide by 2. Divide by 2. But this requires a systematic process to solve this. This looks harmless, but you must use a full-blown trig method on this. This needs to be a theta, and then you can answer the question. When there's a 2x, you can't answer the question. So what I'm going to do is replace this. Let's just call it alpha. This is for my own sanity. I can answer this question all day. This question, sine is negative here and here. You got an angle here. You got an angle here. I know the unit circle number is 60 degrees, 60 degrees. Therefore, 240 and 300, I dominated that thing. Now, we're solving for 2x, and 2x is alpha. So I do know that alpha is 240 and alpha is 300, but there's a trick. Not even a trick. This is the method, and do it for the rest of your life. When you're in this particular situation, when there's not a 1 in front of the variable, then you must do this plus 360, because sine, cosine, secant, cosecant, repeater are 360, and you go plus 360. Now you go alpha equals 2x. And then you go divide by 2, divide by 2, divide by 2, divide by 2. And then the next one you go divide by 2, 2, 2, 2. It's kind of fun if you like think it's fun. Now, by the way, you got to make it fun. You got to think it's fun. That's what I'm really trying to say. You got to understand it's 4 in the morning. I haven't finished my first cup of coffee. I don't care what this is. I'm the dude that made it up. 120 plus 180n, and x equals 150 plus 180n, where n is an element of the integers, double bar z. The integers are just 0, plus or minus 1, plus or minus 2, plus or minus 3. It generates all the solutions to this problem. So you go let n equal 0. Then you go 0, 0, 120, 150. Let n be 1. So 150 and 180 is 330. And 300. Let n be 2. And it's over 360, so those are your 4 answers, except somebody may want radians. That kind of hurts right there. All right, I'm gonna work another very trivial problem, very similar. But I'm working radians. This is an extra. So, example from me. Whoa, had a little, my stand fell apart here. Cosine 4x equals a unit circle number. So cosine, I don't like this problem. There's got to be an alpha. I can answer it. This makes it 100% I can yell out the answers to this. I just got to remember where cosine's negative and where's the square root of 3 over 2. Unfortunately, that's at the 30s. Therefore, that's 150. That's 210. Now, I said it was going to work in radians. So the answer is alpha equals 5 pi over 6. And it repeats every 2 pi, 2n pi. And alpha equals 7 pi over 6, because that's 210, plus 2n pi. Now, with the 4x, divide by 4 8 times. Whoa, here, put it there. Dividing by 4 and multiplying by 1/4 is the same thing. I'm going to multiply by 1/4. And nobody cares about the alphas. You're the one that created it. And this is x, and this is x. So 5 pi over 24 plus n pi over 2. 7 pi over 24 plus n pi over 2. Here's the trick to work in radians. Get the common denominators to be the same. So put 12s in there. And watch this. We're going to zing out the answers. So you go n equals 0. This stuff isn't there. 5 pi over 24. 7 pi over 24. Now, if n is 1, you're really adding 12 pi over 24. So we'll go plus 12. Plus 12. Plus 12. 43. Nope, 41. Add 12. I guess add 2 to this. Add 2 to this. How do I know to stop? Because if I would have added 12 to this, this would be 53 pi over 24. This number is bigger than 2, bigger than, not 0, of course it is, bigger than 2. And you don't want to go past 2 pi. Give me a second here. Oh, sorry guys. That's I didn't mean to. I meant to pause it. Uh, um, I'll write it in the notes here. Maybe this will help. There's a delay around 16 minutes. 2-minute delay. 2-minute. Sorry, that's my bad. Usually I have pause. I was cooking green chili and I needed to stir it, and then my dog woke up and I had to let him out. So that's kind of awkward. All right, so let's do one. So tangent 3x, so I see that special argument coming, plus secant 3x equals 2 on 0 to 2 pi. And once again, the book says, don't include 2 pi. This does not make me feel really good because I got 2 trig functions. It just means you got to get rid of one somehow. Secants and tangents, I do know that secant squared x equals tangent squared x plus 1. So it'd be really lovely to somehow get like a secant squared minus tangent squared if possible. So here we go. I'm going to push this over here. It didn't really matter. I could work it. I could use this trick. Um, I could use this trick. Well, actually, yeah. Oops. We'll see. Oh, give me a second, but I'll hit pause this time. I don't mean to sound crazy, but maybe there wasn't a 2 minute delay. I think I just hit stop recording instead of pause. I'm going to get the squareds to appear. I'm going to make them appear. Now, I don't know if anybody likes it when somebody shows off and does all this in their head. 4. All right. So you get minus 4 secant, so minus 4 secant 3x, and plus secant squared 3x. Now understand, anytime you square both sides, you potentially added solutions. So we're going to have to check to see if they're actually solutions. That's true in algebra. Now, the reason I didn't square it here is I would have got a plus secant squared. But since I moved it over, I knew I'd get a plus secant squared, and then I could move it back and get a minus secant squared. Seems like a dirty trick in a way. Ooh. I'm going to go this direction so I can get a secant squared minus tangent squared. And if you get a secant squared minus tangent squared, you get 1. Wow. So this is 0. I'm pitching it right. Secant squared minus tangent squared, so 0, is 1. 4 plus 1 is 5, minus 4 secant 3x. One trig function, too bad it's not a theta or an alpha in my case. 4 secant 3x equals 5. Secant 3x equals 5/4, and not a unit circle number. Therefore, we're going to need our calculator. I'm going to switch it to a cosine problem. Reciprocate left, reciprocate right. See, still not a unit circle number. Switch it to cosine alpha, because that's the name of the game. That's the new thing. And when is cosine positive, I'm going to find a reference angle, which if this was negative, I would ignore it. Since it's positive, I just do what it is. And I get on, mode. Gonna work in degrees. It shouldn't work in degrees. I just always do. 4 divided by 5. I'll show you a different trick this time. So I know it's 36 degrees. And 869 can go 360 minus the last answer, and you get 323.130. Now switch the mode to radians and repeat procedure. So you go up and select, and you get the radian answer, 0.6435. Stow alpha A, and we're going to go 360 minus the last answer, and we get 359.356. Stow alpha B. So this is A, this is B. So the answer is 0.643 plus 2n pi, and alpha is excuse me, did I even get it? Oh, that was weird. I screwed up something. So it's 2 pi, take away, oh, it wasn't 360 minus the answer. That was dumb. I was working in radians. 2 pi minus this guy was definitely thinking about maybe my green chili. So I'm going to store that in alpha B. So this is in B. So 5.639 plus 2n pi. Let n equals, I got to solve for x. And my calculator's in the way. Here, view, tool. There we go. That'll help. Yeah, alpha is 3x. So divide everything 3x, divide by 4, 8 3's, 1z, 2z, 3z, 4z, and again, these don't matter. You got x by itself. So x equals basically a divided by 3. Alpha a divided by 3. Stow alpha a. So x equals 0.214 plus 2 pi over 3n, and x equals alpha b, verify, divided by 3, 1.879, stow it back in b, plus 2 pi over 3n, and then let's kick out our answers. So this is a, so alpha a, so my answers are, trying to do it cutely, so n is 0, you get 0.214, 1.879, n is 1, so you got to go alpha a plus 2 pi divided by 3 times 1, and you get 2.308. Reselect, plug in a 2, 4.403, and select times 3, enter, 6.497, but 2 pi is 6.28, so stop, and then reselect, go back up here, switch this to alpha B, and you get your 3.974, reselect, enter, switch to 2, enter, 6.068, and those are my radian answers. I actually enjoyed that. I actually like using the calculator. As soon as you figure out how to use your stow buttons and go back, reselect, you know, it makes it tolerable. If you just do it like keeping 5 decimals, I don't know, it might take you an eternity. Next. Oh, I never checked them. Oh. Where did I go? Oh, man, I need to switch pages here. All right, let's switch pages. Oh, back up the truck. Man, I actually went that long without changing pages. The PDF's gonna be terrible. Okay. I'm gonna double check the book because I'm lazy. And there's only well, oh, you know what? I apologize, and I'm not gonna rework it. No, actually, this is so cool. So how is it different than the book? The book converted everything to tangents, and tangents repeat every 180. I use secants and they repeat every 360. So I was going to rework the whole thing because the book actually had 12 answers and I had 6. It turns out that this is an answer and this is an answer and this is an answer, and these guys are extraneous because when you square both sides, you're supposed to check. Now, it's painful to check. Nobody's like checking, even when they're a youngster. You got to take your answers and plug them in the original equation, and it's going to be difficult because they're not nice. So, additionally, you should graph the original. So the very first equation, you should graph that. So y equals tangent 3x parenthesis plus 1 divided by cosine 3x. See how I did that? And 2. Delete, delete. Window 0 to 2 pi. Going by pi divided by 15s. Let me see. Pi over 6 going by pi over 12s. It doesn't matter, but my ticks are basically every 15 degrees because pi over 6 is 30, pi over 12 is 15. And I really don't know where to set my scale except for the 2 is a horizontal line. So I'm going to hit graph, and so there's the first graph. I'm bolding it. And when does it equal 2? Right here, right here, right here. Only 3 answers. I had 6. Second, calculate 0. And once again, you're probably thinking in MML, why wouldn't I do this every time? And oopsie daisy, I don't know what I did wrong there. Graph, second, calculate a point of intersection, enter, 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 4.403. I think I went off my screen with my cursor. You could find a 3 that way, but at least you know you got 3. Well, let me pull it together here. Here's a trivial problem. This is in a book, example 5, page 785. 2 sine x over 2 equals 1. Sine x over 2 equals 1/2. Unit circle number. That's not sine x, so I gotta like make a temporary substitution in my mind. I know these answers. Sine's positive here and here, 30, 150. Therefore, alpha equals pi over 6 plus 2n pi, and alpha equals 5 pi over 6 plus 2n pi. That alpha is x over 2, and multiply by 8 2's. Don't care about 2 alpha. X equals pi over 3 plus 4 n pi. Alpha equals 10 pi over 6. Oopsie daisy. Reduced 10/6 is 5/3. Therefore, pi over 3, 5 pi over 3. And if you add, let n be 1, add 4 pi, pass 2 pi. Those are your 2 answers. Great day. Boy, the book took forever and a day to work that. All right. The thing that makes it tough example 7 seems like just a regular problem. So in real life, this looks like, oh yeah, I should be able to do some stuff. For example, I have an identity for this, and it's plus or minus, half angle formula. I have an identity for this. I'm going to use the one with just cosine x in it. So 2 cosine squared x minus 1. Now, that doesn't help me because I don't know how to go from sine to cosine. When the arguments are different, I was feeling good just getting into here. You know, I got some cosines going, but that method I just used isn't going to work. You know, you got to remember, you do like sine squared plus cosine squared, but they got to be of the same argument. So even if you square both sides, that's not going to be a good thing. The arguments are going to be different. So sine squared of 3x plus cosine squared of 2x is not 1. So it'd be cool, you know, to try it. The bad thing is you pick up extra answers. So you get sine squared 3x plus 2 sine 3x cosine 2x plus cosine squared 2x equals, well, just 1 plus cosine x over 2. This is not 1. And you can't use the double angle formula for sine because they got to be like a 2x and a 2x. The book is saying use your calculator and cheat. I'm just saying if you've seen this problem in the field, you would try it and you would be very disgusted with it. The nice thing about the book is they go solve it and you're like, oh, it has a nice answer. In the real world, you go solve it and you're like, well, it could just be terrible. So welcome to my world, people. You guys are lucky. They go, here's a problem. It has answers. It's no fun when it doesn't have answers. And in addition, I always cheat. So, you know, the book is saying, you know, hey, you should cheat this time. I am like, I don't need to be told. I'm old. I know to cheat. You guys should try it and get good at it. Window, watch this, 0 to 360. I don't mind whether I'm working in degrees or radians. And I never know about the range. -3 to 3 works, been working. Whoa, look at that. Oh, oh, ouch, ouch. Not fun. When does the first graph equal the second graph? I am scared. I am scared. Something went crazy here. Let me see if I can recover. Sine 3x plus cosine 2x, x over 2. First thing I'm going to do is switch. Oh, I hate every switch of degrees. Okay, here we go. Now let's try graph. Whoa, there's the first graph. Look at that graph. 1, 2, 3, 4. Oh, it has 1, 2, 3, 4, 5 answers. And I'll find one. Second, calculate a point of intersect. Why did I work degrees? Because I want to know if it's a nice answer or not. Okay, 201 degrees, not a unit circle number. Therefore, let me switch it to radians. So if you want to switch to radians, you go mode, radians, window, 2 pi by pi divided by 12's graph. You get exactly the same thing. And then you find the 4, 5 radian answers, and 1 is 0. 0.727, 2.288, 3.524, 4.189. Once again, second, calculate a point of intersect, and you just go get one. Let's go get the last one, and you go enter, 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 and you get 4.1887902 match. And go second, calc, intersect, and you have a little clicking party, and you get 3.52. Life is good. All right, now I was pretty careful about not picking some of these really remote applied problems. So there is example 8 and 9 in the book, but I know I didn't select the problem, so we're not going to worry about it. If I had my way, we would stay in these two sections for a month, 10.5, 10.6. We'd work every problem by hand. We'd work every problem on MML. You know, in my opinion, this is what the course is about. As always, especially this time of year, give me a text. Reasonable guy, need an extension, need 5 extensions. I understand. Give me a text, tell me who you are. Taking class online isn't always ideal. By the way, I think this is a pretty good class to take online because literally we're only studying 6 trig functions. I think it's just insane to try calculus online unless you have double or triple the time. So you're going to have to make a lot of time for your next class. Anyway, give me a text. I have no problems extending your assignment, but just know there is a certain day where I need to enter your final grades. So, you know, we'll try to hold to the schedule if possible, but understand, you know, there is a day where the department says you must enter your grades, so everything's got to be done so I can give you, you know, your maximal grade. So first worry about the concepts and then worry about getting your stuff done, I guess. Okay, you guys are great. I'll get on the next section. Remember, I already did all these lectures and now I'm redoing it because I had a hard drive crash. So I'm going to be at this consistently for the next week. And we're out.